All right, we're looking at equations that involve two radicals, like this one right here. See my equation here with two radicals in it? When you have a radical, you need to isolate it and then square both sides. Well, if I look at this problem right here, I've already got this radical over here isolated. So I can go ahead and square both sides. Okay? So when I square this, well, I square the negative, which makes a positive, and I square the radical, which cancels. So on this side of the equals, I got z plus 2. Okay? When I square over here. All right, when I square on this side, I have a binomial. I've got an a plus b squared. When I square a binomial like this, all right, here's what you have to do. You have to square the a, you have to square the b, which is a positive b squared. But I've got to multiply these together and double it because there's the inners and outers from the FOIL method. So this is going to be plus 2ab. Okay? Same thing if you have a minus b and it's squared. I square the a, I square the minus b, which turns into a positive b squared. But then I got to multiply these together. So a times b would be ab, but negative ab. And I double that would be negative 2ab. This is what's forgotten a lot right here, is this little ab thing. So this is what you have when you square a binomial. You square the a, you square the b, and then you got to multiply these together and double it. That's the same thing I have to do there. In this problem, that would be my a, and this radical would be my b. So I would square the a, which would give me a 9. I would square the radical, which would just cancel out and just give me a z minus 13 plus. But then I would have to multiply these together and double it. So 3 times this radical would be 3 radical of that. And then double it would be 6 radical z minus 13. So that's the part right there that's forgotten a lot, or that's left out. Now, once I do this, I still have a radical in my problem. I got rid of this radical, but I still have this one. So it means I'm going to have to square both sides again, which means I need to get this radical isolated. So I'm going to have to subtract 9 on both sides to make that go away. I'm going to have to subtract a z on both sides, which makes that go away, and it cancels that out. I'm going to have to add a 13, which makes that go away. And now I have 6 times the radical of z minus 13 equals, and over here I got 6. Okay? And that looks a lot better. Now, I've got this multiplier in front of this. Now, since this multiplier divides this number over here, I'm going to divide both sides by 6. Okay? Which gives me z minus 13 equals 1. All right, that's perfect. And now I got my radical isolated, and I can square both sides. So I square both sides, which makes this cancel, and I got z minus 13 equals 1 squared, which is 1. And now I can add 13, which makes this go away, and z equals 14. There you go. There's my answer. Okay? But you have to check it, because it's possible we got an extraneous solution. What that means is over here, if I have two things, like if I have a negative 2 and a 2, those are not equal. This is not equal. But if I square both of them, I got a positive 4 and I got a positive 4. Now they are equal. All right? So when I square both sides, I could take something that's not equal and make it equal. So because of this thing right here, I've got to check my 14. I got to check the 14 and make sure it works. So I got to plug it in, have to. So if I put 14 right there, 14 minus 13 is 1. The square root of 1 is 1. So 3 plus 1 would give me a 4 on this side. All right, when I put 14 in here, 14 plus 2 is 16. The square root of 16 is 4, but I got this negative in front, which is negative 4. And they're not equal. So that means this right here was an extraneous solution, which means there's no solution. No solution in this one. Okay, here's another one. Solve this one. It has 2 radicals. See my 2 radicals there? So I need to do the same thing, square both sides, but I got to have a radical isolated, so these are both on the same side. So I fix that really easy. Just add this to both sides. And that makes this go away, which gives me this. I got radical 4y plus 5 equals 3 plus this radical of y minus 1. Okay, and now I got this radical isolated, which means I can square both sides now. And the square cancels the radical. I have 4y plus 5. When I square this, okay, I'm back to this again. I got an a plus b. Here's my a right here. This is my b. I got to square the a, or square the 3, which is a 9. I got to square this radical, which means I have a plus y minus 1. But then I got to multiply 3 times this radical and double it. Well, 3 times that radical would be 3 radical that, and then double it would be 6 radical that, which would be this. Okay? And now, again, I got another radical, so I'm going to have to get this radical isolated, which means I'm going to subtract 9 on both sides to make this go away. I'm going to subtract a y on both sides to make that go away. I'm going to add a 1 on both sides to make this go away. And now I got rid of everything. I've got 6 times this radical equals over here 4y minus y be 3y, and then 5 be negative 3. Okay? Now, this time, which is different than the previous problem we just did, I don't want to divide both sides by 6 because 6 does not divide this over here. So I don't need to do that. I'm just going to leave it. Now, really what I can do, since these are divisible by 3, I could divide by 3 on both sides. That might make it a little bit easier, but I'm just going to leave it as this. And I'm just going to go ahead and square both sides. Okay? So when I square here, well, here you go again. We got this time a minus b squared. So here's my a, and there's my b. So I'm going to square this. So when I square the 3y, I square the 3, which is 9. I square the y. There's what I get when I square the a. I square the b, which would be a positive 9. Then I multiply these together and double it. So 3y times negative 3 would be negative 9y. Double that would be negative 18y. Okay? That should equal, I square this over here. When I square this, I square the 6. I square the radical, which makes the radical go away. And then I got to distribute that, which is 9y squared minus 18y plus 9 equals 36y minus 36 when I distribute here. Okay? And this is quadratic because I got y squared. So I'm going to have to get it equal to 0. Again, if this does not divide both sides, it's going to be murder. So leave it there because it won't divide these. If these were 6's over here, 6y minus 6, I would divide both sides by 6 to get rid of this 6 here. But since it doesn't divide, you leave it. The previous problem, let's go back to the previous problem again. See right here? It divides both sides, so I can divide it. So that makes it easier there that way. But it's going to be murder if I do it here. So I get down to this, I'm going to have to minus 36y. I'm going to have to add 36, and that gives me a 0 over here. I'm setting up the quadratic equation here. This is 9y squared, this is negative 54y, and this is a plus 45. Okay, and I can do the quadratic formula. Now, quickly I realize all these are divisible by 9. So if I divide both sides by 9, this is still 0 over here. This would be a y squared. This would be a minus 6y, and I divide there, I get a 5. Okay? And this factors, but I'm going to do quadratic formula. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. Okay? So now that gives me here 2 negatives makes positive 6. 2 times 1 is 2. I was going to write the radical there, but I got 36 minus 20, which is 16. The square root of 16 would be 4. All right, so I got 6 plus 4, which is 10. Divide by 2, which is 5. There's my answer. I got 6 minus 4, which is 2. Divide by 2, which is 1. And there's my 2 answers, 5 and 1. Okay? But I could have extraneous solutions here, so we've got to go back up here and plug them in. I got 1 and 5. It could be they both work. It could be neither one of them works. So we got to check them. So let's try 1 first. If I put 1 in here, 4 times 1 would be 4, plus 5 would be 9. The square root of 9 is 3. Minus, if I put 1 in there, 1 minus 1 would be 0. The square root of 0 is 0. And 3 minus 0 is 3, so 1 works. Let's try 5. I put 5 in there. 4 times 5 is 20. 20 plus 5 is 25. The square root of 25 would be 5. So this would be 5 here. Okay. Minus. If I put 5 in there, 5 minus 1 is 4. The square root of 4 would be 2. 5 minus 2 is 3. Hey, they both work. So both of those are solutions on this problem. Okay. So there you go. That's all I'm going to do. We got equations with 2 radicals. And if you need help, just yell at me, okay? So have a good rest of the day. Bye-bye.